So in chapter 7.5, we're going to learn how to multiply radical expressions. The objectives in this section are to know how to multiply radicals of the same index, know how to multiply two-term or multi-term radical expressions, and know how to multiply radical expressions with different indexes. Multiplying radical expressions with the same index. When we multiply radicals with the same index, we essentially put the same numbers under the same radical to multiply. In other words, let a and b represent real numbers such that the nth root of a and the nth root of b are both real. Then the nth root of a times b is just equal to the nth root of a times the nth root of b. This property works both ways. So for example, in our example, we have 3 square root of 7 times 2 square root of 14. You will notice we can multiply the coefficients in front of the square root symbols. So we have 3 times 2, and then inside the radical symbol of the square root, we multiply 7 times 14. We notice that we have 6 times the square root of 7 times 7 times 2. We can bring out a 7, so we now have 6 times 7, and we're left with the square root of 2, and so this now becomes 42 square root of 2. If we multiply a two-term expression, in the next example we have 3 square root of 5 plus 4, parentheses closed, parentheses open, 7 square root of 2 minus 5. You will notice we use the distributive property here in order to multiply. So we have 3 square root of 5 times 7 square root of 2. You will notice that then becomes 21 times the square root of 10. Square root of 3 times the square root of 5 times a minus 5 is nothing more than 15. Right? 15 square root of 5. And then we go to the next term. 4 times 7 square root of 2 is nothing more than 28 square root of 2. And finally, we have 4 times a negative 5, which is minus 20. So in this particular case, these are the final results for multiplying the two expressions together. So we're going to try some examples that are in your notes for chapter 7.5. We'll start with the first one where we have the cube root of 4. Then we're going to multiply it using the distributive property. And when we do that, we get the cube root of 4 times 2 minus 3 cube root of 4. Now you can see that this simplifies to 8 because 4 times 2 is 8 and the cube root of 8 is just 2. And then we're left with a minus 3 cube root of 4. We'll go to our next problem here where we have the square root of 5 plus 2 times the square root of 5 minus 2. In this case, we call this a conjunction, and you have a plus and a minus sign for the 2, you see. And so you'll notice that we'll go ahead and use the distributive property again, or FOIL, right? So we'll do this. So when we do this, we get square root of 25. When we multiply the square root of 5 times 5, square root of 5, then the square root of 5 minus 2, so we get 2 square root, negative 2 square root of 5. Then we go to the next term, 2 times the square root of 5 plus 2 square root of 5. And then the final term is 2 times the negative 2 is just a minus 4. Now we'll simplify. The square root of 25 is 5. You'll notice that the 2 square root of 5's cancel, and I'm left with a minus 4. And this just is just 1. We'll go to the next problem. We have square root of 2 times a square root of 2. Again, we're using the distributive property. We get the square root of 4. Then 2 square root of 2 times 5. So we get a plus 5 square root of 2. Now we'll do this. We'll have a minus square root of 2. And finally we have a minus 5, right? So now we'll simplify. We get a 2. Now a plus 5 square root of 2 and a minus square root of 2, they have the same term, square root of 2. So I can just subtract the coefficients, and I'm left with 4 square root of 2. And then finally I have a minus 5 here. And I see that the minus 5 and the 2 will actually combine. So we get a minus 3 plus 4 square root of 2. And that's our answer. In the final problem, again, we're going to use the distributive property. So when we multiply through, we're going to multiply through with the square root of 3. And when we do that, first, we're going to go ahead and we get minus 8 square root of 9. And then we're going to get plus square root of 15 when we multiply the square root of 3 times the square root of 5. And then we're going to multiply the square root of 3 times the square root of 2, and we get a plus square root of 6. So that takes care of the first one. Then we're going to have to do the second one, and we get a minus square root of 5 times a minus 8 square root of 3. Well, that's a plus 8 square root of 15, and I'm going to put it under the same radical symbol here because we'll be able to add those two together. The minus square root of 5 times the plus square root of 5 is going to be a minus square root of 25. And then the final one, we did that, and now we're doing the last one. It's going to be a minus square root of 10. So now we're just going to add all those together. The square root of 9 is 3, so 3 times a minus 8 is a minus 24. This is going to be a plus 9 square root of 15. There's nothing more we can do about that. We get a plus square root of 6, a minus 5 when we take the square root of 25, and then a minus square root of 10. And you'll notice that the 5 and the 24 can add together, so we end up with a minus 29 plus 9 square root of 15 plus square root of 6 minus the square root of 10. And so that is our answer here for this particular problem. So we want to multiply radicals with an index and exponent. The expression of the form here is the nth root of a raised to the nth power. So if we have the nth root of a and it's a real number, then raising it to the nth power is just a. If n is even, then a must be non-negative. So here's some examples. The first example, we have the fourth root of x to the 4, which you know is just x. This is incorrect. That should just be x. Right? So we have the ninth root of x raised to the ninth power is just x. And then the final one, we have 2 cube root of x, y, and z raised to the third power. We apply the third power both to the coefficient and to the radical, and in this case we just end up with 8 because 2 raised to the third power is 8. And then under the radical symbol, since it's the cube root and then that's raised to the third power, it's just what's underneath the radical symbol, which is x, y, and z. So here we're going to do some additional problems with the same ideas of radicals with indexes and exponents. So in the first problem we see 4 raised to the second power, and then we have the square root of 8a squared. This is equal to 16, and in the parentheses this is just 8a. And now when we multiply 8 times 196, we should get 128a. Right. In our next problem, we have the cube root of 7x, and this is squared, and then on the bottom we have this squared. This is just going to be the cube root of 49, because we're going to take the power inside, x squared, and we still have the y squared. The reason this actually works is we can look at it this way. We can have it the cube root of 7x times the cube root of 7x. That's the squared term. And you can see I can multiply inside the radicand and just end up with the cube root of 49x squared. And that's why the numerator is that. In the last problem, this is just pretty simple. Since I'm taking the fifth root of everything underneath 150x squared y, and then I'm raising it to the fifth power, it's just what's under the radicand. In this case, it's just 150x squared y. So now we're going to be multiplying radicals with more than one term. We have the special cases where we have, recall, a plus b squared is equal to a squared plus 2ab plus b squared. We also have a minus b squared is equal to a minus 2ab plus b squared. And then we have the difference of squares where we have a plus b, and a minus b is just the difference of the squares a squared minus b squared. So we learned these back in chapter 5 when we were factoring. And now we're going to apply it actually to our setup here for our expressions. So in this particular case, we have three square root of 2 plus square root of 5, and that's squared. And so we can apply this particular case down to this problem. So you'll notice that the 3 square root of 2 is just the a part, and we square that. And then there's 2 times a, which is there's 3 times square root of 2, times b part, which is square root of 5, plus the b squared, which is square root of 5. And now we can simplify that. 3 squared is 9, and the square of the square root of 2 is just 2. That ends up going to be 18. Then we have 3 times 2, which is 6, and then we have the square root of 2 times the square root of 5, which is going to end up being 10. And then the last term is the square of the square root of 5, which is just 5. So you'll notice that this ends up being 18. This ends up being 6 square root of 10, and the last term is 5. But we can add the 5 and the 18 together, so we end up with 23 plus 6 square root of 10, and so that's our answer here. So again, we're going to try our luck on these special cases. We will write down some of the ideas so that we know, right? We're going to have an a plus b squared issue, and that's an a squared plus 2ab plus b squared. So we have that situation here. So we're going to see that this is going to be square root of 3 squared plus 2 times a, which is square root of 3, times the square root of b, which is the square root of 6. And then the last term is b squared, which is the square root of 6 squared. So now you can see what's going to happen here. The square root squared of 3 is just 3. Then we have plus 2 times the square root of 18, which is that term there, and the final term is just plus 6. Right, so we have 9 plus, now we have 9 times 2, so I can take a 3 out, so that's going to be 6 square root of 2 plus 6, right? And you can see the last idea here, the 6 and the 9 add up, so I get 15 plus 6 square root of 2, and that's our answer here for that problem. Let's look at this problem. Here we have the difference of squares, right? Notice we have the difference of squares, so immediately, what's the difference of squares? It's going to be a squared minus b squared. A in this point is going to be 2 square root of 5, so I'm going to have 2 square root of 5 squared minus the square root of 7 squared, right? So when I square the 2 square root of 5, I get 4 times 5 minus 7, or 20 minus 7, which is just 13. So the answer is 13 there. In the problem over here, we have the situation where we have the following. Notice we have, if we have a squared minus, oh wait a minute, let's try that again here. Let's write that down here. So we have a minus b squared, and that's just a squared minus 2ab plus b squared. So that's what we're going to apply to this particular problem. So here we have 2 square root of 7x squared minus 2 times 2 square root of 7x. That's the a part. The b part is 3. And then the last part is the square of 3. That should be plus, right? So now we can take the square of the 7x. So we have 4 times 7x here. That's going to be how we simplify that. The next term we have a 3 and a 2 is 6 times that is a minus 12 square root of 7x when we simplify that, and then the last term is 9. So we end up with 28x minus 12 square root of 7x plus 9. And so that's the answer for this particular problem. Again, look at what we have here. We have the difference of squares, a squared minus b squared situation. So we'll have the square root of 3 squared minus x squared. So this is just 3 minus x squared, right? So there's your answer for that particular problem. So our last idea is multiplying radicals with different indices. If our radicals have different indices, we can then use the property of rational exponents to obtain a common index, right? So here's our example. Suppose I have the cube root of x times the fourth root of x cubed. We can write this in the exponent form, which is x to the 1/3 times x to the 3/4. The idea now is we have to get the least common denominator so we can add the fractions. Remember, when we multiply variables with exponents, we just add the exponents if we have the same base. And in this case, we have the same base x. So you'll see that the least common denominator is 12, and so we have to change 1/3 to 4/12, and then we have to change 3/4 to 9/12, and when we add it we get 13/12. So that's our final result here. Now in the case where we have numbers, right, we still can apply the indexes. That's not a big deal, but the way we apply the indexes becomes slightly different. So in the case of the fifth root of 2 becomes 2 to the 1/5, and the cube root of 7 becomes 1/3. Now, in this particular case, this should be a 7 here, actually. So in this case, we have to get the same denominator, and 15 is the least common denominator for the 2. So in this case, we'll have 3/15 times 2, and then 5/15 for the 7. This should be 7 times raised to the 5th power times 3 to the 2, and then it's all under 115. So this number is incorrect, and so that number is also going to be incorrect. It's going to be 7 raised to the 5th power. Right, and I can do that real quickly. I didn't see that mistake when I first had the slide. So 7 raised to the 5th power. Well, that's a big number, right? So that's 16807, and then I multiply it by 8 and take it to the 5th root. So that's what's going to ultimately go in here, times 8. Right. So here's our last problems. Again, we're going to apply, we have different indexes, but in this case we have the same base. So we have a to the 1/2 times a to the 3/4. The next idea is to change a to the 2/4. Right, times a to the 3/4, and that's just going to be a to the 2/4 plus 3/4, right? So we end up with a to the 5/4, right? So that's the answer that we get. Of course, we could still apply the radical symbol if we wish to do so. In this case, we could get an a out, and we could be left with, this could be equal to, we can take an a out, and we get the 4th root of a, right? So we take one a out, because it would be a to the 5th, but we're left with an a, so it's the 4th root of a. Here we have different numbers, but that's not a big difference. If we have numbers, we can apply. So we have a 8 to the 1/5 times 3 to the 1/4, right? Now here we want to get to the base of 20, so this is going to be 8 to the 4/20 times 3 to the 5th 20th, right? So you can see now we're going to end up with the 20th index of 8 raised to the 4th power times 3 to the 5th power, right? And now if we do the math on that, right, which I think I have done, right, I get a very large number. I get the 20th power, or the 20th root of 99535328, right? So that's a big number. So you take the 8 raised to the 4th power times 3 to the 5th power, and it's all under the radical symbol of 20. Now here in this problem here, right, we're going to treat the 2x as a single variable. So in this particular case, I'm going to get 2x raised to the 1/5 times 2x raised to the 4/3, right? Now again, we want 15 as the common denominator for the fractions. So here I get 2x, I get times 3/15 times 2x raised to the 20th over 15, and you can see now that this is going to be nothing more than 2x. When I add these two together, I get 23 over 15, right? So even though this is the answer, I could apply the radical symbol. Once I take one out, I could get a 2x out, and I'm left with the 15th root of 2x raised to the 8th power, right? So I could do that if I wish to do so. Then we have these areas, the exact areas that we would want to find. This area here, remember what area is? Area is equal to length times width, right? So this area here is just going to be 5 square root of x times square root of 121x, right? So the area is equal to 5 square root of x times 11 square root of x, right? And so the 11's multiply together, the 11 times the 5, so the area is nothing more than 55 and square root of x squared, so we just get area is equal to 55x. That's our answer for that one. This one's a little bit more complicated, but again, we can do the area is 7 minus square root of 5 times 3 plus the square root of 5, right? So we get 21 when we multiply that times that. We get a plus 7 square root of 5 minus 3 square root of 5, and then a square root of 5 times square root of 5 minus is going to be a minus 5. So we get a minus 5 plus 21 is 16. And then these two coefficients of the square root of 5 will add. In this case, they'll subtract. And I'm left with 4 square root of 5. So that's the answer for that particular area. Please work on continuing the problems in the notes in Chapter 7.5, work additional problems, and look at the answers that are on Blackboard for this section. And I will see you on Monday.